All right, good morning and welcome to the first lesson of the semester for trigonometry. Just kind of to catch you up to speed, if you're watching this on video, that probably means you aren't coming to class. So I want to encourage you, if you go to It's Learning, if you don't know when your class meets, over on the right side on my page, here's the schedule. Just figure out which period you have me. So some of you have me first, some of you have me 11th, some of you have me 6th, 8th, and just check which days you meet and what time you meet, and then try to join promptly, and just go to this website and type in the code FOX. Now you have to be signed in your Wayne email for that to work, so please do that. Also, anytime you want to access my resources, up here at the top, click resources, then choose whatever the chapter is. So in our case here, there's chapter 6, that's what we're on. Has the notes page at the top for you. Here's the day. You click in there, it'll have the link to the video and whatever the assignment is. Sometimes that assignment might be in Delta Math, sometimes Desmos, sometimes It's Learning, but it will always be linked in It's Learning, so you know what you need to do. So today we are going to start trig, and we're going to talk about the 6 different trigonometric functions. Now, when I first say that, I'm guessing lots of you are like, what is he talking about? So let me remind you, if you had me for geometry, you'd remember SOHCAHTOA, right? Our chant. So SOHCAHTOA, sine, cosine, tangent. Now we're also going to learn today there's 3 others, cosecant, secant, and cotangent, that you haven't talked about probably before. So first, let's identify what are the 3 sides of our triangle. Okay, so the 3 different parts of our triangle, we have the opposite side, the adjacent side, and then finally the hypotenuse. Now, when we're identifying them, if we look here at this triangle, we've got a right triangle. So anytime there's that square, that means 90 degrees, it's a right triangle. Here, this sign is theta. That's like a Greek letter. It just is the angle that we're concerned with. So that's theta. Now, opposite. So we're going to represent this with an O, and it is opposite of theta. If you're wondering how to spell that, theta is Theta. So O is opposite of theta, meaning if we're at theta, opposite across it, this side. Another way to think of opposite would be the one side that does not make up the angle. So like this side makes up the angle, this side also makes up the angle. Okay, now our next one, adjacent. This word adjacent means next to, or like beside, so next to theta. So that would be down here. It's right beside it. Now I know some of you might think this one is also next to it. I agree, except that is our hypotenuse because it is opposite from the right angle. So it's across there from the right angle. So H is always going to be opposite of your right angle. Also, your hypotenuse is your longest side. So if it's drawn for you, if you have a visual, you can know just by measuring if you needed to. So opposite of the right angle. Okay, so as we already said, we have the obvious SOHCAHTOA. I'm hoping you guys still remember that, or at least remember that memory trick. And then we're also going to need to flip these to get the others. And I'll explain what I mean by that in just a second. All right, so to start off, we got sine, cosine, and tangent. Now, sine, I know you're used to seeing it SIN. It's actually spelled SINE, but the abbreviation right there, SIN, that's what's on the calculator. So sine is O over H, or opposite over hypotenuse. These are essentially just different ratios that allow us to kind of know some things about our triangle. Okay, so Ka stands for cosine, and once again I'll underline the abbreviation there, COS, and that's adjacent over hypotenuse. Okay, and then our final one that you are familiar with already, tan or tangent, and TOA, so that's opposite over adjacent. And right there, tan is what we are going to use if we abbreviate. Now we also have 3 others. So cosecant. And this one, the abbreviation, since we can't use the first 3 letters because COS is the same, so it's actually CSC. And we flip these. So instead of O over H, it's H over O. Our next one is just secant. And the same thing applies. Instead of A over H, it flips, and it's H over A. And this one, the abbreviation is just SEC because that's not the same as any of the previous ones. And then our final one, cotangent. And the abbreviation just COT. And then once again, it's flipped, so it's going to be A over O. Now, if we are identifying them, here we have our triangle. It's a right triangle. And we can identify all 6 of these pretty easily. However, the first thing we want to do, so our first step is let's label our triangle. Now, when I say label it, what I mean is we want to put an O, an A, and an H on it. So, in my opinion, the H is the easiest. You always know where the right angle is. Just go across from that. That's your hypotenuse. Now, O means opposite. So if you got to find theta, O would be across. So there's O. A is beside. It's the adjacent. It's next to. So that's right there, the 4. And now we're ready to go. Now, hopefully you notice if theta had switched up here, these 2 would switch places. The H would stay the same, but the O and the A would switch, depending on where theta's at. So you'll notice sine, cosine, tangent, cosecant, secant, and cotangent. They are written out in entirety here. I didn't abbreviate them. But so sine is opposite over hypotenuse. So in our case, the opposite is 3, the hypotenuse is 5. So all we have to do is 3 over 5. Now cosecant, we know we just flip that, so it'll be 5 over 3. Okay, our next one, cosine, adjacent over hypotenuse. So in our case, that's going to be 4 over 5. If we flip that for the secant, 5 over 4. Finally, tan for TOA, O over A, so 3 over 4. And then cotangent is 4 over 3. Now, your sine and cosine, the bigger number will always have to be on the bottom because it's the hypotenuse. And cosecant and secant, the bigger number will always be on top. So keep that in mind. With tangent and cotangent, it could be either way. So let's keep going. And in this case, we're asked to find the value of sine, cosine, and tangent, which is pretty easy if we have all the sides. But notice there's a missing side here. We don't know what the hypotenuse is. Okay? So how do we find that missing side? Hopefully, you guys remember this word right here, the Pythagorean theorem. And I'm guessing many of you could tell me what it is. So a squared, or if you couldn't, now that I've said this, you could finish it out. So a squared plus b squared equals c squared. Remember that c is always the hypotenuse. Okay? So in our case, we don't know what the hypotenuse is, because if we label this here, here's our h. It's across from that right angle. Now here's theta, so next to it is adjacent. Across from it, or opposite. Okay. So we got it labeled. Now I need to figure out what that side is. So it does not matter which of these is your A or your B. because keep in mind this a squared is not the same as this a, but you can plug it in there, it's fine. So if we have a squared plus b squared equals c squared, then we're going to do 5 squared plus 12 squared will equal c squared. Gives us 25 plus 144. That equals c squared. We add those together, we get 169 equals c squared. To get rid of that square, we have to take the square root. So we do it to both sides. And hopefully you know the square root of 169, 13. Now, some of you might be saying, what about plus or minus 13? Keep in mind the hypotenuse is a distance here we're measuring. It has to be a positive number. Okay? So our hypotenuse is 13. So if it helps you, let's write that over here. And I'll change color so we can just keep things separate. Our sine of theta. So remember so opposite over hypotenuse. So 12 over 13. Ca. So the cos is 5 over 13. And then toa, so the tangent. So toa, opposite over adjacent, in our case, is going to be 12 over 5. All right. Now, this final one we're going to do today, it asks us to find the value of all 6 trig functions. Now, before we can do that, once again, we need to figure out what this side is, this missing side. So it's going to be set up a little different. Before we had the hypotenuse missing, now we have one of the legs missing. So it doesn't matter which one, the a squared or the b squared, but if we solve this, let me switch back. We're going to have a squared plus b squared equals c squared. I'll plug in that one for b, the square root of 3 for c. 1 squared is just 1. The square root of 3 squared, think about it, the square root of 3 squared, those will cancel out and they'll take care of each other, and we're left with just 3. Now from here, we need to subtract this 1 over. A squared equals 2. We take the square root of both sides. A equals the square root of 2. Now, some of you might be ready to pop into your calculator, figure that out. However, when we're dealing with this chapter in trig, we're going to say no decimals. Okay, we want to leave it as a radical. So I'll put that square root of 2 here. Now, let's go ahead and label this triangle. So our hypotenuse, the easiest one, across from the right angle. Now, theta is here, so right beside it, that's adjacent. This is opposite. All right, so now our goal is to get sine of theta, which you guys know is O over H. So let me write this over here, because square root of 2 over square root of 3. That's a problem. Anytime we have a square root on the bottom, it is not considered like our proper term. Okay, so we need to do something called rationalize the denominator. Okay, so to rationalize the denominator, we need to get rid of that square root on the bottom. And the easiest way to do that is just to multiply it by itself, because the square root of 3, if we multiply it by the square root of 3, square root of 3 times square root of 3 just becomes 3. However, if we choose to multiply by the square root of 3 on the bottom, we also have to do it by the square root of 3 on top. What we are doing essentially, remember, square root of 3 over square root of 3, that would reduce to just 1. We're multiplying this by 1, but in a way that changes what it looks like. We're just changing it. It's the same number, exact same value, but we're changing what it looks like. So as we do that, across the top, square root of 2 times square root of 3 becomes square root of 6. And on the bottom, we'll get 3. And we can stop right there. So square root of 6 over 3. Now, our next one, cos. Same process, except instead of the square root of 2 on top, it was a 1 on top. So 1 over square root of 3, but once again, we'll have to multiply by the square root of 3 over square root of 3. So we'll get the square root of 3 over 3. That's our cos. Now tan. This one is O over A. So we're actually fine on this. It's just going to be square root of 2 over 1. Now from here, for the last three, these ones maybe you're going to have to look back at your notes to remember what they are. I know you haven't learned them yet, but cosecant of theta. Remember, for this one, we just take the sign and we flip it. So you have a couple options. You can either take the 3 over the square root of 6, as we'd flip that, and then simplify it. Or you can take the original one here and flip it. Either way, you should get the same answer. Now, I'm going to start with the original. So instead of square root of 2 over square root of 3, it would have been square root of 3 over square root of 2. Still have to rationalize the denominator. And we get square root of 6 over 2. Okay, we're almost done with our notes here. Next, we're going to do the secant of theta, which, once again, we'll start with that 1 over square root of 3. We'll flip it. Now this one, we don't have to rationalize the denominator. We can just put it as square root of 3. And then finally, our cotangent of theta, which if we look here, that was square root of 2 over 1. If we flip that, we'll get 1 over square root of 2. We got to multiply that by square root of 2 over square root of 2. We get square root of 2 over 2 as our answer. So, I know that took a little bit of work, a little practice. Today's assignment, if we look back in here, was a Delta Math assignment. So if you are not yet signed into my Delta Math account, you're going to need to go up here to Intro to Semester 2 and follow the instructions here in the first day's folder. It has some explanations here on how to join. So go ahead and do that. If you have any questions, please reach out. Hope you guys have a great day, and I'll see you in class soon.